हेलो एवरीवन, दिस इज़ निहाल एंड हम सॉल्व करेंगे 3A क्वेश्चन ऑफ 64th BPSC एग्ज़ाम मैथमेटिक्स ऑप्शनल पेपर. So it says that find the center and radius of the circle, and circle is given by the sphere and this plane. That is, if this is a sphere and this sphere is cut by the plane, so this will be circle. So question ask that find the center, this center, let us this is P, and radius, that let this be A, this is O. So then it asks that PA, that is radius of the circle, and center P. So let us solve this question. So the given equation of sphere is x square plus y square plus z square minus 2y minus 4z minus 11 is equal to 0. In the standard form of sphere equation, we write x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d is equal to 0. That means here in the given equation of sphere, u, v, w, d are u is equal to 0, v is equal to 1 minus 1, and w is equal to minus 2, and d is equal to minus 11. So radius of sphere r, let us discuss first this PA. PA is equal to, by Pythagoras theorem, PA, this is perpendicular from O to P, O to this plane, and this is radius of sphere. So PA ka square plus OP ka square is equal to OA ka square, that is R square, radius of given sphere. So PA ka square is equal to R square minus OP square. That means first we need to find the radius of sphere, and then we need to find OP, that is perpendicular distance from center of the given sphere to the plane, that is OP. So then we can obtain this PA. So let us first find capital R, that is radius of a sphere, which is equal to under root u square plus v square plus w square minus d, which is equal to u is 0 plus 1 plus 4 and plus 11, and this is under root 16, that is 4. So r is equal to 4. Now let us find OP. So OP is a perpendicular distance from center to plane. So what is the center of the sphere? Center of the sphere is minus u minus v minus w, that is 0, 1 and 2. So from 0, 1 and 2 to this given plane equation is x plus 2y plus 2z is equal to 15. X plus 2y plus 2z is equal to 15. So how do we find the perpendicular distance of a point from a given plane? So what we do is OP is equal to, we write in place of x, y and z this given point 0, 1, 2. So this is 0 plus 2 plus 4 minus 15 ka mod divided by, we do sum of square of coefficient of x, y and z, and then take the under root. So this will be 0 plus 4 plus 4, and this will be 1. So coefficient is 1 here. So this is equal to 9 by 3, that is 3. So OP is 3. So what will be AP? AP, that is radius of circle. radius of circle is equal to under root r square minus op square, that is 16 minus 9, that is under root 7. So we have found that this is 3, this is under root 7, this is 4. So now we need to find the center of circle. So what is the center of circle? This is this point P is a center of circle. So how will we find it? We will first write the equation of OP line. When we write equation of OP line, and then we will find the coordinates of the point which is 3 unit far from O. So let us first write the equation of OP line. O is given by 0, 1, 2, 0, 1, 2, because it is minus U, minus V and minus W, center of sphere, which is equal to 0, 1, 2. And distance of this point from this plane is 3. So let us, and what are the direction cosine of perpendicular of the plane is 1, 2, 2. That is these are direction ratios, so direction cosine are 1, 1 and 1 divided by 3, 1 by 3, 2 by 3 and 2 by 3. These are direction cosine of perpendicular to the plane, that is direction cosine of the perpendicular line, that is OP. So let us first write the equation of OP. It is x minus 0 divided by 1 by 3 is equal to y minus 1 divided by 2 by 3 is equal to z minus 2 divided by 2 by 3 is equal to r. So the points on this line can be written as r by 3, 2r by 3 plus 1 and 2r by 3 plus 2. So here r is distance from this point O. So we need to find the coordinate of point P, and P is 3 unit far from O. Far from O. So what is value of r? R is equal to 3. Let us put this value of r and we can find the coordinate of P. So this will be 3 by 3 and this will be 2 plus 1. This will be 2 plus 2. That is 1, 3, 4. This is the coordinate of point P. So this question is done. The radius center of circle is 1, 3, 4 and the radius is under root 7. So this was the a simple question asked in the BRPCS 64th BRPCS mains examination. Now let us solve the question number 3B of 64th BRPCS mains examination mathematics optional paper. It asks that find the curvature and torsion of the curve, and curve given by r vector r is equal to x coordinate is given as a into u minus sin u and a 1 minus cos u and bu. So let us solve this question. First of all, let us write the formula for curvature and torsion. Curvature, try to remember these formulas. Curvature denoted by kappa is equal to dr upon du into d square r upon du square mod divided by dr upon du. In books it can be written as dr upon dt. Instead of u it is written as t because r is a function of t there and here it is u, so we write u. And formula of torsion is given as triple product of dr upon du, d square r upon du square and d cube r upon du cube. triple product of these divided by dr upon du cross d square r upon du square ka whole square. So these two formulas, try to remember these and implement in the question directly. So let us write what is r. R is equal to a u minus sin u and b 1 minus cos u and bu. Let us first find dr upon du, d square r upon du square and d cube r upon du cube. So dr upon du is equal to a 1 minus cos u and this is b sin u and this is b. D square r upon du square is equal to a sin u and this is a this is a only, so a cos u and this is 0. D cube r upon du cube is equal to a cos u minus a sin u and this is 0. So now let us find the cross product of dr upon du into d square r upon du square is equal to determinant of matrix I j k a 1 minus cos u a sin u and this is b a sin u and this is a cos u and this is 0. So if we find the determinant, we will get iota into minus ba cos u minus j minus ba sin u and this is k a square 1 minus cos u into cos u minus a square sin u, which is equal to minus ba cos u I plus ba sin u j plus k a square cos u minus 1. Now on simplification we can get this. Now let us find the modulus of this product, because in the formula of curvature we need this. So modulus of this cross product is dr upon du cross d square u r upon du square, which is equal to under root b square a square cos square u plus b square a square sin square u and plus a4 cos u minus 1 ka whole square, and which can be written, a can be taken outside, a under root b square plus a square cos u minus 1 ka whole square. This is equation 1, or it further can be simplified as a under root b square plus a square and this is 4 sin square sin 4 u by 2 and this is equation 1. Now let us find the modulus of dr upon du which is equal to under root a square 1 minus cos u का whole square plus a square sin square u plus b square, which can be written as under root a square plus a square cos square u minus 2a square cos u plus a square sin square u plus b square, which can be further simplified because this and this will become a square. So this is 2a square minus 2a square cos u plus b square. So 2a square can be taken outside and 1 minus cos u will become 2 sin square u by 2. So this will become 4a square sin square u by 2 plus b square. So now putting these two from equation 1 and 2, this is equation 1 which is modulus of cross product, and equation 2 in the formula of curvature formula is that modulus of cross product dr upon du into d square u upon d square r upon du square divided by dr upon du का cube. So this will be equal to this a b square plus 4a square sin 4 u by 2 की power 1 by 2 divided by 4a square sin square u by 2 plus b square की power 3 by 2. So this is asked curvature. Now let us compute this torsion. What is torsion formula? It is a triple product of these three dr upon du, d square r upon du square and d cube r upon du cube divided by square of cross product, that is dr upon du cross d square r upon du square का whole square. So from equation 1 we already got this, and triple product of this can be find dr upon du d square r upon du square and d cube r upon du cube is equal to cross product of first two dr upon du into d square r upon du square and dot d cube r upon du cube. So this cross product of first two we already calculated. Now we just do dot product with the third one. So this is cross product of first two and this is third one. So what we do is we do dot product of these three. So what we will obtain by doing this is minus a square b cos square u minus a square b sin square u, which is equal to minus a square b. And from equation 3 we already have this one. So this is tau, that is torsion, is equal to minus a square b divided by a square and b square plus 4a square sin 4u by 2. So this a square can be cancelled, so torsion is minus b divided by b square plus 4a square sin 4u by 2. So this is answer. Thank you guys. You can join Telegram group to ask your